All right, so it's number 2, man. How you doing?
I'm fine, and what about you?
Good. So last time we had CRT and Mahmoud. We introduced the world of Mahmoud.
Absolutely.
And he actually agreed to do a lecture on advanced CRT. You guys are going to see that probably in a couple weeks. So
That's
rock
great.
and roll. Now, there's a little thing that happened a couple weeks ago down in Anaheim.
Absolutely. We finally did that Build Windows event.
Yeah.
And we could finally introduce all those technologies we were saying for so long we cannot talk at this time, etc. So we put all together in the table.
Excellent. And C++ was as first class as I've ever seen it
Yes,
at
yes,
any
yes,
of
yes,
our
yes.
recent big developer conferences, and that was nice.
Probably, like in 10 years, we didn't have, so much exposure as we had 2 weeks ago in Anaheim.
Now, as the community guy for your team, you've been following the tweets and the Facebooks and all the stuff going around. What's the reaction from native developers to what you guys unleashed down there?
I can tell you for sure that the reception was phenomenal. I mean, you can check today, there is a series of Metro-style apps forums that were created, for people to start opening threads and discuss on these technologies, and it's unbelievable the amount of activity that are happening there, in a daily basis. So I'm tracking that, and it's like, I'm really delighted about that. We can say that there is like a sort of traditional C++ audience who also, welcome these changes. They were mostly curious about some extensions we introduced, to the language. Yes, in order to create components in an easier manner,
Okay.
However, in the other side, you have the community of .NET developers, and because the concepts that are being introduced in those extensions, are really familiar for them, if you have like events, interfaces, etc. For them, the reading was just like, I can still do the things I was doing these last 10 years, but now I can compile this natively, so we'll run just directly on the metal. So the reception was phenomenal. So, this is something that I'd probably like to invite a friend of mine, Tarek, and he can explain better, how these two worlds are related.
Excellent. So let's beam this guy in.
Absolutely.
All right.
Okay.
Ready? Energized, bro. Wow, man. How was the trip?
It was great.
Excellent. Excellent. So we were just talking about C++ at Build.
Absolutely. And some, like splitting the reactions in the audience, certain people trying to, already using the extensions, and some people saying, why couldn't we get, like a sort of wrapping ISO C++, compliant APIs, in order to create components without the complexities of COM. So what do you have to say about this?
Yeah, we certainly heard that during the conference. One of the things that we absolutely wanted to do as we were designing the Windows runtime and how C++ works on top of the Windows runtime was to give developers a premier experience for how their code is going to look like.
Okay.
And one of our most important things was to make sure that the code is maintainable, readable, and fluid. So you can actually, call into a function, check results quickly, and call from the results of one, get the other, and that led us to a number of design alternatives that we looked at.
Okay.
Some of the alternatives we looked at were library-based alternatives, 100% library-based. Other alternatives that we looked at included some modifications to the language or some additions to new language features that made the code look more readable. And as we went through it, we actually ended up with a good set of new features that we added to the language that we believe bring the true essence of Windows runtime to C++, and one of the most important things there, for example, is reference counting. So being able to make sure that we capture that and allow developers to leverage it easily. Now, with that said, we also understand that for some people it's very important to maintain the lowest level of control possible over the Windows runtime, and we're talking about C++ developers, so we absolutely understand that that is a necessity. So one of the things that we also created was the Windows runtime library. And there's actually a short story to that. When we first created the Windows runtime and we were about how do we create the components of the Windows runtime? One of our requirements was, okay, we have to have something now that allows us to build those components.
Sure.
So we created the WRL, which is defined in WRL.h that we actually shipped in the developer preview. And with that one, we actually used it internally to create most of the WRL of the Windows runtime component and expose those. And while we were creating the Windows runtime components, we were also creating the new language features that we added to Visual C++ to consume those Windows runtime components. So the end result is, we have a beautiful new set of language features that we expect that the majority of developers will want to use, because they make consuming the Windows runtime and calling Windows runtime APIs significantly simpler from C++. But we also provide the lowest level control if you really, really want to with WRL to be able to call into that.
Absolutely. I have, like just a first question that is coming to my mind. When you try to solve the problem via language extensions, it's because you are planning to resolve those in compilation time. Is that correct? So you have also the alternative of using libraries in order to wrap all that inside the library. So is the library being resolved at runtime and the extensions are going to be resolved at compilation time, or actually once you compile a program using the extensions, it will look exactly like one using the W?
That's a good question, Diego. The libraries and the new language features achieve similar objectives, which is allowing you to generate code that targets the the Windows 8 runtime. The syntax looks a little bit different, and one of them is a lot more verbose. The library, for example, WRL, is a lot more verbose than the language, but also the language hides away some of the details of the Windows runtime that you probably as a developer don't need to deal with on a day-to-day basis. Like, for example, where your output parameters come and throwing an exception out of that, or the fact that we're doing some level of reference counting that is happening, or how the lifetime of that is managed across from one module to another. But with the library, you can have further control over that. But the end result is the generated code is code that directly targets the Windows runtime. It's native x86 or x64 or ARM code that targets the Windows runtime, and it uses the same features out of the Windows runtime. So whether you're using the language or using the library, essentially you're using the same features from Windows 8 that are exposed. We do some of the machinery and heavy lifting for you using the language. You could do that manually using the library if you really care.
All right, Tarek, so one of the things I've been noticing on Channel 9 and also on Channel 9 Live at Build, and you're going to see some of that stuff if we ever get it encoded, is essentially C++ developers are asking two things. This looks like C++ CLI. Is it managed? And number two, I want to use ISO C++. I don't want to use an extension. What do you tell those people?
That's a very good question as well, Charles. First on your first part of the question, is this managed? And by managed, I'm assuming, is this .NET code running there? Because it looks like C++ CLI and C++ CLI targeted .NET. No, it is not .NET code. There is absolutely nothing there that binds to the .NET framework or the CLR, the Common Language Runtime. It is 100% generated code for the targeted chip, so whether it's x86, x64, or ARM.
Excellent. There you go. Okay.
Yes, and additionally, there is also sort of a philosophical part of this. Is like what constitutes, what makes managed? Like, is any runtime managed? Like, was COM managed, for example? If you have runtime services in the operating system that do something like reference counting, do you consider that managed? Well, that is a philosophical question that will always exist. But yes, there are some runtime services in Windows 8 that the language relies on, as it has always been the case. But absolutely, there is no CLR or .NET in that story. Even though the language syntax we've similar, because some of the concepts are sort of map. It is absolutely no .NET in there.
For sure, because it's not any common language runtime on it. It's not intermediate language what is being compiled.
That's correct. There is no JITting happening, for example. We don't generate intermediate language that gets JITted. There is no garbage collection happening. There is none of that.
So you just use it services being like the reference counting services that the operating system is providing, but your compiled code is running on the metal.
One of the goals for when, the Windows runtime was to provide an ABI safe for exposing components, and WinRT is that, and C++ for the Windows runtime allows you to use that ABI safe boundary and expose it and use it.
Okay.
Cool. So you're hiding a lot of the COM complexity.
We're hiding a lot of the Windows runtime complexity.
Now, for those who like COM complexity, but I guess maybe we should go to the second part of the question first.
Yeah, you asked about ISO. You asked about
which is super important. We've been pushing it really hard, man.
Sure.
With the C++ renaissance.
You know what? Our customers have been pushing it very hard. We absolutely believe in ISO C++.
Great.
You know, and we sort of talk about new language features, and you know, some people get out of that yes, you know, this is a new language. Go rewrite all your code. Absolutely, that's not what we're saying. You know, well, it's very important to be clear about what it is that we're asking people to do. Windows runtime is how you call into Windows 8. So this exposes a new Windows 8 API set, and we created new language features that allow you to use language constructs when you're calling into those APIs. That doesn't mean that all your code now needs to look like this. In fact, what we really expect C++ developers to do is to continue to write ISO C++ for the majority of their code. You know, we expect that, you know, you have a large core engine there, or you have a deep business logic or application logic, and that you actually worked hard to make that ISO C++ for whatever reason. You know, it could be conformance, it could be some portability, it could be anything. And we absolutely want you to continue to do that. Where you're going to run into wanting to use some of the Windows runtime features is where you're calling Windows 8 APIs, because now you're using some new types, you're using you know, ref counted objects, you're starting to use some features of Windows 8 that you can either use, as we said, WRL for, or as we prefer, we use some of those new language features to make your life easier. So that's when you start using the language features. That's when you start using the new types, at that boundary when you're dealing with Windows APIs. Absolutely don't go and rewrite your code. And in fact, that was an important design decisions for why we structured some of the types that we created. If you look at some of those types that we created, whether they're the collections or some of the basic types, we did not create them as rich types that should replace the standard. We made them something that augments your code such that you're able to, you know, trip into the Windows 8 world, as opposed to go rewrite all your code to be like that.
Sure. So I remember, you know, during the times, you know, web services emerged, that the question was also, again, you know, it's like certain people were saying, so we should rewrite all our applications in order to make it available for web services. It was the same question. It's just, you know, like the integration level of your application. Even, I mean, not just the request your applications could receive for any customer, you know, being able to issue request, you know, using web services, but also even if your application in resolving those was, you know, using third parties application, you could also rewrite that portion in order to use web services. So I guess that the concept could apply.
I remember those days. I mean, I think the bottom line is, you know, don't believe anybody that tells you should rewrite your code.
Yes.
You know, you have a great investment, you have great code, you spent years writing that, why should you ever rewrite your code? There are some good reasons for you to decide to do that when you believe that is right.
Absolutely.
Not because somebody invented something new, you should go rewrite your code. For Windows 8, we wanted to think about creating new applications that actually touch first and Metro enabled. You should do that. You're going to need to write a new lot of code for the UI layer and perhaps for other stuff as well, and make sure that, you know, these things, you know, have great battery life and battery life characteristics. But also, where it makes sense, you may need to create those new applications with some existing code from here or there. And you absolutely do not need to rewrite that. Just use it as it is. ISO C++ is just fantastic and great, and we love it, and you should continue to use it.
Great.
Excellent.
We invite you to write more of it.
Good. Now, as far as the WRL, it would be good to know a little bit more about it. Like, for example, why was it designed the way it was? I mean, what's really going on? What does the code look like? When would I use it? Why would I use it? When would I do C++ CX? When would I do WRL? Could I write WRL components that I consume from C++ CX? Obviously, we're going to have scenarios like that, right?
Yes.
When you want to get really nasty with the WinRT and control it, and then have a nice UI layer that interacts with that code.
I'm sure a lot of people would love to know about that stuff. But you know who's actually best to talk to about that stuff? The person who actually wrote WRL.
Nice. Yeah. Can we get him?
Absolutely. You should go talk to Sridhar.
Sridhar.
Yeah.
Okay. Rock and roll, man. Well, hey, thanks for coming into the machine.
Hey, thank you, Charles.
Great to talk to you. Sridhar.
We need to visit that guy.
Let's do it.
All right.
Okay, thank you for coming.
Thanks, Diego.
All right, so we want to know more about WRL, right, Diego?
Yes.
I mean, it's the low-level projection, I guess, in WinRT, and it stands for, it's a template library. So we're here with the author of WRL, Sridhar?
Yeah, I'm Sridhar Madagiri. I'm a developer in the Visual C++ team.
Excellent. So I guess right off the bat, what is WRL?
So WRL is a small template library we wrote for the purpose of targeting Windows runtime, the new API model that we have for Metro apps. And it was designed right from the beginning to target that area. It was not about everything else. It's just very focused on that area.
Absolutely.
It's a small set of template classes, and it's been used a lot internal to Microsoft, and I'm sure it's be useful for people outside of Microsoft as well.
Excellent.
So why do you think, a developer aware about the existence of this would use it, instead of another alternative like the WinRT?
So WRL again is using standard C++ techniques. It is using some of the very advanced techniques as well. But one of the key things about WRL is when we designed it, we said it's going to be very low level. That means it's very close to the ABI, which is COM and things like that. And at that level, there is no exceptions, and there is actually no other overhead. You see what you write. There is nothing hidden from you. In a way, I mean, yes, because of it's a library, I'm sure there's code hidden, but you can step through it. You can see all of it. There is nothing hidden from you. So one of the main reasons you would use it is, let's say you already have some components. You have native components. You are not using any exceptions in there, and now you want to take that component and make it into a WinRT component. You have ActiveX, some component that's in COM. Now you want to move it to WinRT. You don't. That's WRL may be a good candidate for you. There are other issues. We can talk about some of those later on. The other reason is you definitely don't want to use any extensions. You want to stay with the language.
Okay.
That's one of the reasons you might choose to use WRL.
Sure.
But those are sort of the key things. In a way, there is no abstraction.
Okay.
It's very close to the metal.
Understood. Now, in some sense, that's what we would expect as C++ developers. And so, what I'm hearing though is if I'm afraid of the cone, right?
Yes.
And I just want pure C++ or standard C++, and the complexity that's going to come along with that, I will use WRL to write my consumable WinRT components.
So WRL has both components. One is the consuming, and the other one is authoring your components. So you can do both sides of it, and exactly what you said. If you don't if you want to see everything and you're ready to take on that additional work, then WRL is your choice.
Excellent.
Okay. The next topic.
So I mean, the next topic then we need to discuss is your design.
So what was interesting was a while ago we said, okay, you know what, we're coming out with WinRT. We want to write components that are WinRT and consume components that are WinRT. And what do? I mean, we already have libraries like ATL. Why can we reuse and things like that? When we thought about all the things, I mean, so I have worked on ATL for a while. There are other people on this team who designed ATL. So we had a discussion. I talked to a lot of them, and then we thought about what are the key things that we want in here. One of the main things we decided early on was ATL was written, let's say, 10, 15 years ago. During that time, the C++ language, how we use C++ has changed. There are a lot of new techniques. There are a lot of learnings that's happened. So first thing we said was we want to use use all of the learning inside Microsoft, outside Microsoft, from the community. What are the things we have learned, and apply that to WRL. So it uses metaprogramming. I know not everybody is comfortable with that, but we do use metaprogramming.
So template metaprogramming.
Template metaprogramming to make sure you get the most efficient code.
So in some way, it looks like a re-implementation of ATL based on the knowledge that was acquired.
You can put it that way. In one way, you can put it like that.
Okay. However, you cannot target the same platforms, with this or ATL. For ATL is very targeted to the desktop applications.
ATL is very targeted to classic COM, which is mostly desktop.
Absolutely.
We have not done anything in ATL to make it target the WinRT.
Absolutely.
So one of the things, again, coming back to the design thing though, so meta-programming and new techniques, that is sort of, we are writing a library today, let's use all of those.
Sure.
The next thing was, this is about targeting WinRT APIs. What was interesting was, while we were designing WRL, the WinRT APIs from Windows was evolving, so it was always a challenge to keep it in sync, but we were working closely with them, and we made sure that we didn't add something in there that wasn't very critical to the WinRT APIs. So if you think about it, it does not have things like iDispatch, which is classic COM, which is an ATL.
Sure.
We don't have that in WRL because it's not relevant in WinRT.
Absolutely.
So the concepts that are in there are very specific to WinRT. If it's not required by WinRT, it's not there. So some people may find that, hey, this is a very small library. It doesn't have all these other concepts, and that is intentional because we want to keep it to that very focused on that area.
Great. What about exceptions in WRL?
The thing that the WinRT is COM reimagined. I don't know all the right words.
You said that, man.
So it is still COM at the very core of it. So in COM, when you cross the boundaries, there is no exceptions.
Absolutely.
There is nothing. You cannot throw exceptions across your COM boundary and things like that. So WRL from day one doesn't throw any exceptions.
Okay.
However, so let's say you are writing using WRL and you end up using some other class library or anything that, let's even take STL. So let's say you use standard vector, it throws exceptions. So in the face of, so let's say if one of your other component throws exceptions, we are safe in that. In the sense we have tried to make sure that everything is wrapped in smart pointers or smart wrappers or in wrappers, so that in the face of exception, when there's unwind happens, it does clean up. So we don't throw exceptions ourselves. There is no throw anywhere in our code, but in the face of exceptions, we are safe.
Sure.
And that makes sense because you're going to expect people in this new world will be using multiple native frameworks. So the C++ CX stuff on the boundary, I could see using an WRL library that was written against WRL as part of my application, but I've spent most of my time in the C++ CX world, and I'm going to throw exceptions.
Yes.
And so it's interesting. What happens when errors happen in your world, though? You're sending H results?
Yeah, so all these APIs return H results, the standard COM way of handling things. And if you do use exceptions, then you have to make sure that you are protecting your code from not throwing exception across the boundary, because we don't do anything there for you.
Absolutely.
But it is all H results. The other thing, just from one of the other things I just want to let you know from design point of view is, because we targeted for WinRT, it is not a general purpose library. It's not like it doesn't have everything in the world that you want. It is very targeted. Absolutely. So right from the beginning, we didn't set out to say, hey, we need a big new library here. This is a library that's for this very specific area.
Great.
But I mean, just to kind of hammer home on this, besides exceptions, I still would like to talk a little bit more about why you've done this, because it's still not super clear, because it's a thin abstraction over WinRT, close to the ABI surface. We understand that. But if I bring in a bunch of other code that's also really low level, that traditionally worked in a non-WinRT runtime, I mean, do you understand what I'm trying to ask?
So let's say you already have ATL. Why did we write WRL? So one of the things also was, what's interesting is a lot of the Windows components, WinRT components, are written using WRL. So they were designing these APIs, there was a big churn, and we are doing the other thing about trying to do the language projection, and any change in the API specification or the WinRT specification has a huge impact on our language projections. But being a library, it's much easier to write it. And there's also a chicken and egg problem. How if I'm trying to design two things at the same time, I can't use one to do the other a lot of times.
Sure.
So WRL is really used for a lot of Windows WinRT components.
Okay.
That's one thing. Now, if you talk about ATL, why didn't we use ATL? The thing was, ATL has a lot of other concepts in it which are not related to WinRT, and we don't want people to wander into that by mistake and take dependencies on that, and then once they're done and then realize, hey, I'm taking a dependency on something that's not there. The other thing is, a lot of people, this is a new API. If we come up with a very clean library, it's easy to program there.
Sure.
And it's yes, you can take ATL and write WinRT components, I'm sure, even though we have not updated ATL. But I'm sure there's quite a bit of work involved in making it happen.
Makes sense.
Use WRL, man. That's
Yes.
the point of it.
Yes.
Just wanted to kind of hammer home this because there isn't too much information about this out there already.
Yes.
But of course, there will be a white paper
Yes.
with lots of code and much more
Absolutely.
deep analysis.
Yes.
There's also a great session Dion Brewis did in build, and it's like he started talking about the extensions on WinRT. Later he started talking what is happening under the hood.
Yes.
And it's like that is how the community actually learn about this, this runtime library, and they started asking us,
Yeah.
So
The other interesting thing is, I think, if you look at ATL versus WRL, right? I mean, WRL is definitely what Dion was talking about. It's that very low level,
yes.
but you don't have to do all that by yourself. WRL gives you a lot of those
Sure.
things for you, but at that same level. But the other thing between ATL and WRL is that ATL has a lot of flexibility in terms of saying, hey, I want to customize this to the very minute level. And what we figured out was most of our ATL users didn't use all of those features. And what happened over time is, like, people are like, oh, why is it there? Is it important to me or not? And when we started WRL, we wanted to start from, here's very core stuff. Hey, I want this new feature. Okay, we are going to add that feature because now it's a feature that everybody is requesting. So if as I was saying, since Windows is using that, if we got a request from like one person saying, I want this feature, we normally said, can you just go implement that in your own component, because this doesn't seem to be a more common thing. But at the same time, there were some requests that came up, hey, I'm trying to do X, and it came from 4 or 5 different people, which means immediately we said, okay, it is a concept that's very common, and we should come up with a component. What's very interesting is, I'm sure all of you who are seeing this is going to go look up WRL at some point and see the classes there. One of those interesting classes that came up as a result of requests from people who are using WRL was like the asynchronous state management. So the Windows spec has this thing saying, okay, when you're doing an asynchronous component and these are the states, these are the values you should return when you're in these states. And people were like saying, can you give us a reference thing? Can I just use a component that will do that automatically for me, and I can plug in my code in there? And so that's one of the classes that came about as a result of people saying, hey, this is a common thing, please give us a way to do that automatically.
Excellent.
So are there examples of using WRL in the own implementation of those Windows components? It's in the WinRT developer preview, for instance, or
a lot of the components that you use end up using are written in WRL, except you don't see it because it's a binary interface.
Sure.
You would not see that unless you have Windows code.
Sure.
But lot of those are written. I mean, let's take for example, like one of the first things I think you will do when you are trying to write an application is to use the application object, which is written in WRL, or you're trying to use URI, which uses WRL to do its.
Great. So my point is that we are dogfooding our own.
We are dogfooding
in the operating system.
In the operating system.
Great.
And the interesting thing is also that as the specs changed, and we did the implementation, somebody went and said, hey, this spec needs to change a little bit. We were talking to each other, and so we updated it as we went along. And sometimes there was a difference between the spec of WinRT and the implementation in WRL, and we got a bug. And we said, does it make sense to actually change the spec, or does it make sense to change WRL? Because sometimes we found out that our implementation was wrong. Sometimes we found out, it's a reasonable implementation, the spec needs to go and change. So it very closely tracks the spec.
Interesting.
Very, very interesting. That's one of the confusions that we're seeing from customers. I know Diego's been following a lot of the tweets and all the stuff that the community does, is this notion of for writing a native Metro app, that you would have a high-level native syntax, which looks like C++ CLI.
Yes.
It's not managed. Everybody knows that already. It's crystal clear. People need to get this through their heads. It's not managed code.
Yes.
Then you also have WRL, right? But in some sense, the higher level C++ CX, it's native.
It is
native. It just generates WRL for you, right, to some degree? Can you talk about that relationship?
Yeah, I mean, I was involved even in the C++ CX design and discussions and implementation. So I'm sort of looked at both places, used both of them. Yes, I mean, so the key thing here is that WRL is very low level. You may have to sometimes write 50 lines of code. And with C++ CX, you may have to write 2 lines of code, because there's a tool that generates that 50 lines for you.
Yes.
But definitely the C++ CX looks like C++ CLI, and internally we have had questions which say, oh, I'm writing this Metro app with managed C++. It's like, what is managed C++? It's because they see that it's the C++ CLI syntax, there's a confusion. It's definitely native. There is no CLR loaded when you use that. And it's very interesting, very easy to try it. Just write a small app, run it, and you should not see any of MS Core Lib or any of the CLR DLLs being loaded.
But I think everybody understands that now.
So that's the first thing. And the other thing is, yes, WRL does this through a library. C++ CX does it through a tool, which is the compiler.
Sure.
So inherently, if you're running code to look at some information and generate code, you can do a lot more. Whereas when you're in a library situation, it's like you have to write more yourself, because there is no tool running to generate all that code for you.
Sure.
But at the same time, though, C++ CX is definitely generating code that's very low level. And in fact, couple of concepts, when you build up a binary, we actually pull in WRL into your binary.
Okay.
Because we didn't have to rewrite that part. Where there was nothing special about it. And yes, it may not be part of your binary. As a part of the process, it loads up code written in WRL.
Great.
Excellent, man. That's really, it's clearly one of the big confusions we've seen, and that's kind of what we're trying to do on this episode of Going Native, is address what the world has been telling us.
Yeah. I mean, I can go through some samples, or we can talk more about design or whatever, but maybe some samples may be interesting.
I think it would be great.
Right. But anyway, so there are some key concepts. So let's talk about a authoring scenario.
Absolutely. Right.
So I want to write a WinRT component. So what would I do first? I mean, so if you think about COM, let's see what you need to do in COM, and then we can see what you need to do with WRL and MoCOM, and I think that will give people sort of a view of what is required, what is different, and things like that. So you would write a idle file in COM, and then you would, out of this, you get a .h file by running middle.
Okay, sure.
And then here's then you have your .cpp files, some set of files. You have used something. Let's just say ATL for this purposes, but you could be using some other library that supports creating COM components. So you have this, and then basically you build So then you take this, you compile all of these, and then you get a .dll, let's say.
Okay.
Right. So you have a COM component in a DLL. So what do we do here? Here we have the definitions. Of interfaces, and whatever else you say, okay, some other types that you have that goes across the boundary, right? Here you have your implementation. So you implement your interfaces, and then you build all of this, and then you get this binary. And there is things here which is, let's put that here, and then there is registration.
Yeah.
So where does ATL help you? ATL really just helps you with this part.
Understand.
So this is sort of your COM world.
Okay.
So now if we go to WRL, okay, this one, okay, we have a idle. It's the same thing. There's nothing changed there, because obviously we have a library solution, and WinRT still uses idle, except the difference between these two is that in this world, WinRT allows you to have some different set of constructs in the idle,
Sure.
and that you can figure out from our documentation. But generally, it's still definitions of interfaces and runtime classes.
Okay.
And then here you're going to say you have a .cpp file, and you're going to use WRL. And then you'll, so again here, if we service, you have a .h, which generates the C++ definition of these interfaces you have in idle.
Sure.
You compile everything, and then you get the DLL.
Okay.
And in the one of the interesting things that's changed in the Metro apps is that there is no concept of registration in the on the system. It's not like
Sure.
you can register the component. They have the Apex manifest, and the manifest contains the information to activate your component.
Right.
So there is registration which is manifest.
But it's an implicit registration in this case.
Yes, I mean, so earlier we had it in COM as well. It was called reg-free COM, but they have, so the Apex manifest really contains information about the WinRT components you have created, and
Right.
so it's there. And where does WRL come in? It comes in here.
Okay.
So most of your other steps still remain the same. This registration, ATL gave you some help, but now you need to create a manifest. And we already have some tools that can take a WinMD file and create a manifest. So here we also create a WinMD.
Yep.
Here we would create a TLB. So in the new world, WinMD is sort of, you can consider to be the equivalent of a TLB in the
Right.
old world. So that's really where WRL's places. So that gives you sort of the overall view of authoring.
Absolutely.
Excellent.
So now let's focus a little bit in this box.
Okay.
So I'm going to
Erase the old COM.
old COM. So first thing is, okay, I include my component. I'm getting that from idle with all my interfaces.
Okay.
Okay, so first thing you want to do is, okay, you want to create a WinRT object. And let's say you have a couple of interfaces you want to implement. Of course, let's include WRL headers. I'm not trying to be very specific here. I'm just trying
That's
to say
fine. It's
what it is.
whiteboard coding.
Yeah. Okay. You want to have a runtime class that implements interface. Okay. Class my component. Okay, so you're creating the component, and now you want to implement. Let's say I interface 1 and I interface 2.
Okay.
You have two interfaces you want to implement, and what does it mean from COM? We need to, so in WinRT, everything derives from IInspectable. IInspectable, it's a new interface which derives from IUnknown.
Aha.
So you have to implement addref and release from IUnknown. You have to implement query interface, and you have to implement the new interfaces from IInspectable.
Okay.
And ATL gave you ways of doing that, and we'll give you ways of doing that in WRL. So, okay, these are the two things you want to implement. So now you say run time class template.
Ah.
So that way you get it implemented for you.
So these, we won't implement the interface,
sure,
but we'll implement, by doing this,
yes,
we will implement query interface and addref and release, which is ref counting.
Great.
And we implement get IIDs, which is a
great,
which also is similar to query interface in the sense it returns the list of interface IDs that you implement.
Okay.
Okay, so this gives you 4 out of the 6 functions you need to implement in every WinRT object. And here you're going to interface 1, right? You'll implement those methods. We don't know what you want to do there. It's up to you to implement. And I interface 2. You're going to implement those methods.
sure.
Okay, so we have implemented 4 out of the 6. We need to implement 2 more methods of IInspectable. So for that, we have a macro. We tried to minimize number of macros, but we ended up with 2 macros. So you're going to say inspectable.
Nice.
Inspectable class. The first one is the name of the run. So one of the interesting things, I don't know if everyone knows, is in COM you had something called GUIDs, which was the class ID of the object you wanted to activate.
Okay.
In WinRT, it's a string. The activation, it's not a GUID, it's not a class ID. The way you activate is this a string,
Okay.
and
So easy to read. when
easy
you are
to
checking.
read, and things like that. So it's a different way of doing.
Okay.
in
So
WinRT.
but how is the string generated?
So this is what you say.
Okay.
This is my.
You put the string you want.
Here's where you're saying this is the name of my.
Sure. So you choose that.
This is the ID of my class.
Okay.
Unlike GUIs, in those cases were generated. Am I wrong?
In COM, this would be a GUID. This is a string here.
And the idea behind GUIDs was that you guaranteed uniqueness, or
Yes.
quote unquote
Yes.
guaranteed uniqueness.
Yes.
That sounds
Okay,
dangerous.
so
Can you,
actually, the requirement is since it's a whiteboard, I'm just leaving it out. So normally you want to say company
oh, okay.
dot how much. It's a namespace thing.
Got it.
Okay.
So you can put whatever. I'll just leave it for my.
So there are still ways to minimize
Sure.
Yeah.
classes.
So that is one information, and
Sure.
that gives you the information for implementing one of the interfaces, one of the
Absolutely.
methods of IInspectable.
Okay.
That's great.
And then there's a trust level. So here you would say, you would specify what the trust level of your component is. Okay, so there's no semicolon required really, but okay. So now you have a fully a WinRT a object, a class that implements a WinRT object.
Sure.
So it's implemented all the IUnknown methods for you, the IInspectable methods for you. You don't need to do anything else. You specify your interface in one place, and you're done.
Great.
However, this is still not activatable. So in COM, you had to do something to activate, and which is basically you are registering things, and you had to wire up code in. You needed a class factory.
Sure.
So there's also a factory in WinRT. So we need to wire it up somehow.
Okay.
So This is where the second macro comes in.
Okay.
ACTI, activatable class, and the name of your semicolons not required again, but it's a habit to just put it there.
Sure.
So now you have a activatable class, activatable WinRT component that you can use using WRL.
Excellent.
There's one more thing, which is the last thing which you always hit even when you do ATL, is the exports. Obviously we have this code, we need to call it from outside somehow. So
Sure.
in COM you had DLL get class factory. In WinRT you have DLL get activation factory, if I remember. Yeah, I think it's DLL get activation factory.
Okay.
So this is this one, and you will write one more, maybe another source file which has these standard exports, and all you would do there is like mostly boilerplate code, unless you want to tweak it in any way, where you would call into one of the components, WRL components that will be available to you, and you would just say get module, let's say it's DLL, colon the name of the export, because there are 3 or 4 exports you have to do. DLL can unload now, and DLL get activation factory. So when you say get module and the type, we have static functions on that that corresponds to those 2 exports. You just call it, and all this is wired up for you.
Okay.
Great.
That's great.
Now, if you're writing a Metro app in C++ CX, you would just use this file. You just use this code from your thing. So I guess really what I'm trying to say is there's the notion of public sealed for the boundary layer objects.
Yes.
In this case, this would just be, in this example, could just be WRL that does some really great fast performance code for me or whatever.
Yeah.
I use inside my context. I can still have somebody from JavaScript call into my boundary layer, which is public sealed, and we're good.
Yes.
I just wanted to throw that out there because that's sort of the Metro.
Yeah.
Great.
So again, this is about writing code. You have to write your manifest, you have to write your idle and everything.
Isn't the manifest generated for you? I mean.
So the I don't remember exactly how it's all integrated in the IDE. So let's say you're writing it with the command line.
Sure.
Let's say you're running all the tools from command line, you're not using IDE anywhere.
Okay.
Then you have to do each of these steps.
Yes,
our IDE helps you with certain steps.
Of course.
Great.
But again, manifest is not the last step, right? You have to do also the Apex package and deploy and all those things.
Absolutely.
So of course there is help in the IDE, but I don't want to sort of bring the whole thing because we want to focus on this part.
Absolutely.
But those things are sort of outside the context of WRL specifically.
Yes.
So you could imagine the developer who's going to actually write this code, this functional code, could just pass that on to somebody else. I could package it up into the larger picture.
Definitely. Yeah.
But it's the notion of programming close to the WinRT metal.
Yes.
And that's what this is for.
Yes. And this is, I was talking earlier about metaprogramming. This is where there's a huge amount of metaprogramming happening with this line. And it's sometimes when you're not looked at it for a while, it takes you 5 minutes to really, oh, this is what we did here. So it is interesting code.
So template metaprogramming you've used to implement this.
Yes.
So functional programming.
Yes, to automatically give you the query interface, get IDs, and all that.
So let's talk a little bit about in your implementation. This will be interesting because we've talked a lot about on Channel 9 and of course the VC blog and all over the place, but mainly coming out of Microsoft from our perspective. Modern C++. Are you utilizing in your implementation details, sort of, clearly you're not using variadic templates because they're not implemented.
It's not there.
But hopefully maybe someday, but we don't know. We can't talk about that. We don't know. But really what I'm asking you, how much modern stuff are you using in your implementation details?
So I think we are using almost anything that was there at the beginning of, let's say anything that was in the product in Dev 10.
Okay.
So you're using Lambdas?
Visual Studio 2010.
Okay.
Sure.
I don't think we needed to use Lambdas anyway, so we didn't use it.
Okay.
Again, we used concepts that were required, but we also didn't want to try to use everything.
Understood.
No, it was not a goal, and makes sense, absolutely.
Yeah. And the reason that we sort of kept at the whatever was at the beginning of Visual Studio, at the beginning of our this version of Visual Studio is so that we were not trying to design something that would depend on a feature that may or may not come, and so.
Understood.
And if there was something that we actually required, we would have pushed the team to try to get it. But other than VariDect templates, I don't think we needed anything newer than that. Unfortunately, we couldn't get that, but
yes.
When we have it,
well, I mean, you know, just go. Herb's not that far from you, man. You should.
Yeah, it's actually next door.
So you should go. Did you go over and go, Herb? Come on, man. Right on.
Yes. No, the interesting part about that, you know, I think that maybe people watching this video will feel identified is that you have to evolve something, and you are using tools that are evolving in parallel. You know? I used to work, you know, in large projects where people were building libraries, and I was building code supposed to use those libraries that were still evolving, you know, and it's like
it's a chicken and egg problem a lot of times. And in this case, we already had one, which was WinRT APIs was evolving, and we were trying to be parallel with this one, and we didn't want to put one more
and exactly what
variable in there.
You were telling that happened something that I felt immediately, you know, identify that. There were certain clashes, you know, or misconceptions between the two teams, and in certain cases, okay, we actually needed to change the implementation of the library, and in some other cases, the specification of the new language should be changed, you know. So, interesting lesson.
Totally.
Yeah.
Great.
And then there's like.
So, go ahead.
Continue. No, continue.
So this is sort of your very simple one, right? But and now you might ask, it's like, how is it very different? I mean, if I'm writing with C++, CX, it looks like very similar. Why is it any different? I think where you would have to end up starting to write more code in WRL is in more complex scenarios. And I'm sure we can have some other talk or some white paper or blogs that actually compare the WRL to C++ CX, and then let people choose which one they want to use, right?
Sure.
It's possible to do almost everything that you want to do in C++ CX or WRL, but except WRL. Also, I don't want people to just look at this and think, oh, this is pretty simple, because as the concepts get more complex, the amount of code you have to write becomes more and more.
It makes sense. I mean, that's something that we stressed on the show in our introduction was, you know, C++ CX is native code.
Yes.
You're going to get performant compiler output. There is no intermediate step.
Yes.
It's native code.
Yes.
So, you know, some of the fear that we see, some of the developers, I mean, in defense of native developers, though, they, as Scott Myers talks about, they like to push the boundaries of the circle of computing. Yes. And they want to know how far they can push things. Totally. So if you're going to generate a bunch of COM for them, they may get a little concerned that, hey, I might want to go in and twiddle this little piece, just like I might want to use inline assembly.
Totally agree. And that's an interesting point that you bring up. Today, the build developer preview bits don't allow you to make C++, CX, and WRL very easily. So right now we are working on, we know the problem, and so we are trying to work on things to make that happen. I'm sure we'll have something by RTM. In fact, just before we started talking, I was working on one part of it to see how we can make it work. So, so we are working on that. So even if you come up with a scenario where you're saying, hey, you know what, I want to use WRL right now. And at some point you decide, the next component I write, maybe I don't want to do all this. I know what is happening here. I looked at what's happening in C++ CX. I want to write my next class that's part of the same application with C++ CX. You should be able to mix them together.
Great.
The interesting thing here is we wrote this one, right? So we have written all of these. And let's say you decide that you have a DLL with 2 WinRT components, one you're already in with WRL and you don't want to invest time to go rewrite it with C++CX. But now you want to use your C++CX in your second component. It should be as simple as saying, I'm going to just sort of make up something here, ref class, my second component, lack of better name, and you're going to implement whatever you want. And maybe with the exception of the part that I was talking about, the exports, you do this, you build it, it should work for you.
Great.
So we definitely want to make sure people are using what's comfortable for them.
Sure.
But at the same time, if they become comfortable with the extensions and they want to mix it here, it should be possible to do that at some level.
Well, you're touching an interesting point, because something that is noticeable based on the feedback we got from people, it turns out we don't know yet how it's going to be used, but traditional C++ developers perhaps will give a chance to the WRL and try to understand the internals. And something I noticed is that seasoned .NET developers who are looking to introduce more native code because of the power and performance of C++, they feel pretty comfortable with certain concepts that are associated with the extensions because of this aspect we were commenting, that the syntax is pretty similar to something they already knew, that is the C++ CLI, you know, on exceptions and pure interfaces, etc. You know, so it may happen that traditional C++ developers will stack on the WRL and C# developers will use the winner.
So the way I would put it more though is, I think people should go we have given them two solutions.
Sure.
Wherever they feel comfortable, they should go there.
Absolutely.
And if they choose to go to the other place after having tried one, I think we are trying to make sure that it's easy for them to use either of them, at least at some level of interaction. I don't know if I can tell you right now whether I can use one concept of WRL and one concept of C++CX in the same class, but at least we want to make sure that it's possible at the binary level.
Absolutely. And I mean, the model that seems to be most compelling is the notion of hybrid. Hybrid computation, a hybrid computing. And so that you could have the nice, the boundary layer stuff in C++ CX and have some hardcore, like unbelievably performant, like I want to control every single operation kind of stuff in WRL. You build up the package that the end user gets a beautiful experience, and you have still a fully native app.
That's true. I mean, I totally agree with you. Not all components are equal, right? There could be some component in your code which is about, let's say, setting up some settings of your app, and you don't really care about the performance or how it's written. But you may say, oh, you know what, I have this, whatever a picture encoder, decoder, or I'm just putting it to voicemail. Encoder, decoder, or something like that, which I want to be really close to the metal, and you could choose to write that in WRL. So it could be just not how comfortable you are. You could choose different tools for different.
Absolutely, and then you could even, let us even say you could do something in JavaScript or C# in the same package.
Absolutely.
You could have C# and WRL in the same package. I'm not saying in the same code file, obviously. But in the same package.
Absolutely.
It's a really interesting world.
I mean, I'm totally excited because now what's happening is you can choose your language that you are comfortable with, and maybe you are comfortable with multiple, and depending on your need, you can choose which one you want. You can use WRL, which is very close. You have to do a lot more work, but you get what you write. To the level of JavaScript, where I'm sure that level of abstraction is way more than C# or C++ CX.
Great.
Excellent. Well, hey, great to meet you, Sridhar. Thank you. It's been excellent.
Thanks for.
Now we want to come back and hopefully we'll see you again. Maybe as it evolves. We can we'll come and see you again, or you can come down to our studio.
So one of the things that we're actually thinking of was, I mean, I'm one of the persons who worked on WRL. There are a couple of other people who are now working on more actively than I am. I did sort of a lot of the initial design and implementation. Now other people have taken over. So one of the things I'm trying to do is, as a whole, we want to write some white papers about WRL. we want to write blog entries, we want to have samples and things like that.
Sure. Great.
I'm sure Diego will.
Yes, we are looking forward to receiving that. When I say we, I'm talking on behalf of the audience. Beside myself.
And I'm sure Diego will announce as those resources are available.
Sure. Yes,
so, but
definitely.
I mean, I'm really excited about WRL and C++CX because I'm involved in both of them. So I know the strengths and weaknesses of both. So it's a really good experience in both of those.
Great. Well, great work, and thank you for evolving the platform, man. It's wonderful.
Thanks.
Cheers.
Thank you. Okay, so
man, wow.
I need to ask you a personal question.
Now
that you learn a little bit about both worlds, you know, the extended language and the libraries, which one do you think you are likely to use?
Well, to be perfectly honest with you, for a Windows 8 Metro style app, I will use C++CX to do a lot of my sort of UI logic and the things related to experience, right? Immersive experience, the stuff, the marketing stuff. But that's really what it's all about. However, I want to use and will use WRL when I need to get down to the level of having maximum control over the Windows runtime.
Makes sense.
And even though it's not really a runtime in the sense, there are runtime services happening for you, automatic reference counting and stuff. And what I did really like on the whiteboard, at least the code he showed us, that looks like simplified COM to me.
Yes.
Like higher level COM. And what did you think about that?
I mean, definitely, you know, it's the idea. It's like bringing COM to those who consider COM so complicated that was something they would never like to mess with, you know? So that's the idea, you know. In my personal case, I also, for sure, I'm a ISO C++ guy as well, you know, trying to make my applications as portable as possible, even if I'm not thinking on port my applications tomorrow, you know. So I am likely to concentrate the bulk of my code, you know, on, you know, the business, I mean, the application logic, trying to do that as standard as possible, and try to just write, you know, a thin layer using the extensions in order to get the thing done as fast as possible, you know, and integrate it with the rest of the operating system.
That's a great point. And as Tarek was talking about, I could just consume a library I've already written.
Absolutely.
And just do the thin layer. I do wonder how thin that layer will be, though. And so we'll see. I mean, I hope you guys will start writing apps on the developer preview and really, you know, push the boundaries and see what you can do with WRL. Write your, as you were saying, the nice boundary layer. Let's see how thick that boundary ends up being from a code perspective.
Absolutely.
And bring in your physics and math libraries. I mean, of course.
Maybe, you know, in a future episode, we could bring one of the community guys, because that is already happening, you know. I'm checking in the forums, and the questions they are asking, you know, they said, I'm already trying to port my application. How should I use this and that, etc. So hopefully we will.
So we'll bring him on here.
Yes.
We'll bring you into the machine.
Absolutely.
Rock and roll. Well, you know what time it is, right?
Yes.
You know what time it is?
This was a long episode.
All right, man.
Okay. Delete.